All right, starting part 2 of section 4.1, we want to go back and look at our cosecant and secant graphs, and then we're also going to look at cotangent again real quick. But if I were to draw my cosecant graph, I would have to have my sine curve. So again, plotting your 5 points for your quadrants, then look at those x-intercepts, plot your halves. Again, I'm just kind of freehanding this real quick. So we need our sine curve to draw cosecant, and then at our x-intercepts, because we're taking the reciprocals of all these point values for their y's, if I'm going to be at 0, we know that the reciprocal of that gives me an asymptote line. So at every x-intercept, I'm drawing in an asymptote line. Okay, the next thing we want to do is to plot our points, the 1 and the -1. Then we want to plot our halves. We want to take the reciprocal of a half, which is 2. So where we're at that 1 tick mark, positive 1/2, negative 1/2, we're then going to go to 2 and -2. And there's our cosecant curve. Again, just a quick rough picture. Because again, what we want to do is we want to find its inverse. Well, the problem here is to find our inverse, we have to cut it right here at pi over 2. Because everything after pi over 2 gives us the same positive y values. And we don't want to skip over here to quadrant 3. So what we have to do is go to pi and draw in another curve, if you will. Again, just a quick drawing. And now what we want to do is we want to take, whoops, I want to put that in black. We want to take from that vertex on over. So now for cosecant, our domain restriction is negative pi over 2, comma, we have a vertical asymptote at 0 to positive pi over 2. And if we go ahead and look at y equals cosine of x, all right, normally we start up here at 1 to 0, -1, 0, positive 1, and we put in our halves. And we have to probably put in another portion over here to get our complete U-shaped curves here. So I'll do that real quick. And so again, asymptote, 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 color in the 1, color in the -1. -1/2 become 2's. -1/2 becomes -2's. And here's my secant curve. Just again, a real quick, rough graph. And now as we look at this graph again, we want to restrict its domain. So it's 1 to 1. Well, here, I'm going to take quadrant 1, 0 to pi over 2, head over towards quadrant 2, and cut it through pi. And then that's going to be my domain restriction, because now I get all my possible positive y values, all my possible negative y values, again, going from 0 to pi. But we have a vertical asymptote in the middle of our domain restriction at pi over 2. So we have to take in consideration, take that into consideration. All right, and we'll hold those, we'll come back, and I'll go back to where I was drawing our XY coordinate plane. I don't think we need those triangles anymore. And if we quickly draw cosine or cotangent, there's our y-axis, there's our x-axis, pi over 2, pi, that was the location of my asymptotes. Whoops, give me back my pen, thank you. Between 0 and pi, have the x-intercept at pi over 2, upper half cut in half down to -1, lower half up to 1. There was our cotangent curve. So now, with that domain restriction, whoops, check, asymptote lines, be careful. Parentheses 0 to pi. So if we start to add these back into our list here that we have in our lower half part of the screen, so if we're going to go to cotangent now, cotangent is quadrant 1 and quadrant 2. So inverse cotangent of a positive in quadrant 1, inverse cotangent of a negative is in quadrant 2. Then I'm going to go back to that other tab, looking at our cosecant and our secant. Here was my domain restriction. We were in quadrant 4 and 1. All right, so I go back here for cosecant. 1 and 4. Cosecant inverse of a positive, and then cosecant, inverse cosecant of negatives are in quadrant 4. And then going back to that other tab, looking at secant, we were going from 0 to pi, just like we were for cotangent. All right, so last but not least, our inverse secant of a positive. They're all positive in quadrant 1, and our inverse secant of a negative is in quadrant 2. No inverse is ever in quadrant 3. So we're never going to go there. So that leads us to building that table. So again, we can reference everything here, but I'm pretty sure we have it all now. So let me go to my table. We'll start filling it in. So for inverse sine and inverse cosine, that is your -1 to 1. That's the domain. That's the range of your old sine and cosine. They become the domain, bracket -1 to +1 for both. Tangent and cotangent, well, they both had a range of -infinity to infinity, so that's now the domain of the inverse tangent and inverse cotangent. And as we saw with our cosecant and secant curves, that's where they started at +1 at the bottom of our parabola and went up to infinity. And on the negative side, they started at -1 and went down to -infinity. That was their range, so now that's their domain. So this would represent the parabola opening down. This would represent the parabola opening up for the range of the regular cosecant and secant curves, which are now the domain of the inverse graphs. So our range, now here comes our angle measures. Remember sine, we said it was -pi/2 to pi/2. Cosine was 0 to pi. You're going to start to see a pattern here. Tangent, -pi/2 to pi/2, but with parentheses, not brackets. Inverse cotangent was 0 to pi. Are you starting to see a pattern? Inverse cosecant, bracket -pi/2, to bracket pi over 2 over here, but we had that asymptote line cutting it right down the middle at 0. Okay, look, starts at negative pi over 2, ends at pi over 2. Start, end, start, end. Secant, which is the reciprocal of cosine, start at 0, end at pi. Cotangent, inverse cotangent, start at 0, end at pi. Same with secant, start at 0, end in pi, but we have an asymptote line cutting in half. Inverse cosecant and inverse secant are the only ranges that get cut in half because of that vertical asymptote is now turning into a horizontal asymptote. So again, if you recall, tangent is sine over cosine. Having sine in the numerator dominates their domain and range, especially the range. Sine, negative pi over 2 to pi over 2 with brackets. Inverse tangent, negative pi over 2 to pi over 2, open interval. Sine, which is the reciprocal cosecant inverse, its reciprocal is 1 over sine. Same interval for the range. And then for your cosine, inverse cotangent, which is your difference identity, or excuse me, quotient identity. Cosine in the numerator determines where we're heading, and same thing with 1 over cosine. So these quadrants that were here in our range are 1 and 4 for inverse sine, inverse tangent, inverse cosecant. Now, going back to that chart, there's my 1 and 4. Here's my inverse sine, inverse tangent, inverse cosecant. Everybody's going to be positive in quadrant 1, so there's going to be all quadrant 1s down that last column. And then for our other 3, we're over in quadrant 2. So, whoops, 1 and 2, 1 and 2, 1 and 2. So it's important to understand what quadrants we're going back with our angles when we fill these in. All right, inverse reciprocal functions. We have y equals the inverse secant of 2. And again, I think we had that shortcut here, if you recall. Take the reciprocal of secant, that's cosine. So I'm thinking inverse cosine, and take the reciprocal of the argument. 2 over 1 is 1/2. So I'm guessing we have to rewrite this as y equals the inverse cosine of 1/2. So again, let's go through our steps to double check. Take the secant of both sides to cancel out the inverse secant. Then we say secant of y is 1 over cosine y. 2 is 2 over 1. We flip it. Yep. I see it showing up. There it is. So again, you can use the shortcut or you can always use your steps. So it's positive 1/2, which means we're in quadrant 1. And for cosine, that is a 60-degree or pi over 3 angle measure. Arc cosecant. All right, let's stop and think about that. That would be its reciprocal for cosecant would be sine. So we're looking at inverse sine, then flip this negative 1 over the square root of 2. Let's check. Cosecant of both sides, convert it into sine, flip it, then take inverse sine of both sides. Yep, there it is. All right, so that's a square root of 2, so I'm thinking 45-degree reference angle, but we're down in quadrant 4. So negative 45 degrees or negative pi over 4. All right, part C. Y equals arc cotangent of negative square root of 3. Just like we saw earlier at the end of the last video, this is going to be a quadrant 2 angle, but we can't do the inverse cotangent on your calculator. All right. So if we change this to cotangent y, then take its reciprocal, and we get tangent of y equals 1 over the negative square root of 3. This is going to be a inverse tangent of 1 over negative square root of 3, which is a negative 30 degrees or negative pi over 6 for inverse tangent. But we have to go into quadrant 2. So again, we're going to add 180 degrees to our negative 30, takes us to 150 degrees. add pi to our negative pi over 6, that takes us to 5 pi over 6.